Hello, this is FlippedHarber for Precalculus. In this video we'll cover Section 2.3, Graphing Techniques, Transformations. In this video we'll be talking about vertical and horizontal shifts, horizontal compressions and stretches, vertical compressions and stretches, and reflections about the x-axis and y-axis. The objectives for this lesson are to learn how to graph functions using horizontal and vertical shifts, compressions and stretches, and reflections about the x-axis or y-axis. The outline for this video will start by talking about the shifts, then we'll move on to vertical stretches and compressions, horizontal stretches and compressions, and we'll end with the reflections over the x-axis and y-axis. Now a vertical shift, or again a vertical translation, is when we move the graph up or down without changing the shape of the graph. It just looks like the graph has been slid around without actually changing its shape. Now, we accomplish vertical shifts by adding or subtracting a number at the end of the function. So here we see a parent function, the original function, y equals x squared, and what's often referred to as its daughter function. So this graph was moved up 3 by adding 3 at the end of the function. A horizontal shift is when we move the graph left or right. We accomplish horizontal shifts by adding or subtracting a number, what I like to call as inside, that is, it's with the x. And you'll see that there's a -2 inside a set of parentheses. Now, when you subtract a number, that graph is going to move right. And we'll talk about this at the end of the video. It always seems a little bit weird, but I'll try to make it make sense. A vertical stretch is one where all of the points of the graph are pulled away from the x-axis, either up or down from the x-axis. Now points that are actually on the x-axis do not move. Here we see an absolute value function that's been vertically stretched up and away from the x-axis. Now we accomplish this by multiplying by a number. Specifically, we multiply by a number that's bigger than 1 outside in front of the equation. A vertical compression, all of the points move toward the x-axis. Again, points on the x-axis do not move. So here we see that same absolute value function, but this time it's been vertically compressed. We still multiply, but now we multiply by a number that's smaller than 1 to make that compression happen. A horizontal stretch, you need to think about points being pulled horizontally, that is, pulled to the side. They're getting pulled away from the y-axis. Now, just like the vertical stretches and compressions, points on the y-axis do not move. So here's a cubic function, y equals x cubed, and it's been horizontally stretched by multiplying inside the set of parentheses, inside with the x. But because it's inside, things happen opposite what we would expect. We actually multiply by a number that's smaller than 1 to make this stretch happen. Now, if we want to horizontally compress, that is, move all the points sideways towards the y-axis, again, the points on the y-axis don't move, we actually multiply by a number that's bigger than 1 inside the set of parentheses. Now, reflections about the x-axis. This is a vertical change. Points that are above the x-axis are moving below the x-axis. The points actually keep the same x value, it's just their y value is changing sign. The way we do that is by literally multiplying the whole function by a -1. So here we see that y equals x squared function again reflected over the x-axis, and all we needed to do was put a negative in front of the function. Reflections over the y-axis, this is a horizontal change. Points are moving from one x value to the opposite x value, but they keep the same y value. The way we do that is by putting a negative inside with the x. So we multiply the x in the function by a negative. Here we see a square root function that's been reflected over the y-axis, again by putting a negative inside with the x. Alright, now things seem a little bit weird. Let me give you my rule of thumb, and hopefully it'll help make sense. Vertical changes, that is, if we translate up or down, or we stretch vertically, or we reflect vertically so that it's over the x-axis, all of those changes to the equation happen, what I like to say, as outside in the equation, not in with the x. So we multiply outside, we multiply the whole equation by a number, or we add a number all the way at the end. That's how we change it vertically, and things behave very much like we would expect them to. When we multiply, the graph gets bigger. When we add, the graph moves up. But when we're talking about horizontal changes, those changes show up inside the equation, that is, with the x. And everything happens the exact opposite what we would expect. To make the graph bigger, we divide. To move the graph to the right, we subtract. So they happen opposite what we would expect. Alright, so here's a parent function, f of x equals the square root of x. And here's two daughter functions. How would we have to change the graph of f of x to create the graph for g of x? What's that 2 do, and what's that minus 1 do? Well, that 2 is a vertical stretch of 2. It's outside in front of the function, so it's a vertical change. That minus 1 is inside the function. It's inside with the x, and it's going to horizontally shift it right 1. Alright, let's take a look at h of x. There's a 1/3 and a plus 4. Now that 1/3 is inside with the x, but the plus 4 isn't. That plus 4 is outside that square root. So what would the changes be? Well, the 1/3 is a horizontal stretch of 3, makes it wider. The plus 4 moves it up 4. Alright, so that's it. Just a few minutes out of your evening. I hope you learned a lot. You've got the homework, and I'll see you in class, and I'll see you online.